Postulates, we say, are just statements based off observation, all right, that we can assume to be true, all right? We assume that they're true without proving that they are true. And then theorems, all right, are statements that we can prove to be true. And in this particular chapter, we are going over inductive reasoning. And again, that's just reasoning that uses a number of specific examples to arrive at a conclusion. When you arrive at the conclusion, that is generally called your conjecture, all right? When you assume that an observed pattern will continue, you are applying inductive reasoning. A concluding statement reached using inductive reasoning is called a conjecture, all right? Anybody have any questions? All right, now let's just get to it. All right, so at the top of your paper, let's just go ahead and write this down to make sure we're good. 1 through 10, hopefully you brought your calculator. I think I'm going to show you how to use your calculator or remind you how to use your calculator. All right. So put that at the top of your paper so you know what to do tonight. And now we can start. All right. Oh, okay, I'm sorry. We'll go back. Sorry. Oh, I should have put the page number. I don't remember what page it is now. But it's section 2 dash. What is it? 111. Thank you very much. Page 111. Page 111. All right, you good now, Oliver? All right, thank you, sir. All right, here we go. Let's take a look. Again, guys, should be relatively easy day. All right, write a what? It's really just 1 through 23. And then 31 to 37, and then 40 to 45. All right. All right, now we can start. All right, here we go. All right, so writing the next pattern. All right, that wasn't too hard to see, correct? We're just adding what? For number 1, what are we doing, guys? Yeah, you're adding 225. All right. So the conjecture would just be you're adding 225. All right. And then, of course, find the next item. So that would just be 1125. Anybody have any issues? And so the next one is just adding what? Adding 45 minutes. And so the next one would just be 12:30 what? I was surprised the other day. I was hearing some kids talk about AM and PM and they were confused. It's 12:30 what? PM. All right. Okay. So I don't care about drawing things. You just have to make an observation, right? So does the star change? It's being what? Moved clockwise. Thank you. How many degrees? Yeah. Rotated 90 degrees clockwise. Everybody happy with that? And that's what I'm saying. You don't have to draw that out. All right. Now, can anybody tell me what kind of circles these are called? Those are called concentric circles. Why do you think they're called, or what does concentric circle mean? Tell me, Tanner.
Growing.
Yeah, they are definitely growing. All right, but I can make growing circles that aren't concentric. Who can tell me why they are concentric? That's a pretty good guess. But I can, so what dot did I just put in? What's that called? That dot in the middle. Nobody from pre-algebra days? Where's it located? Let's do that. Where's that dot located? In the center. So that's called the center of the circle. Sorry. I know it's supposed to be some great fancy name, but no, that's called the center of the circle. All right, so what's true about the center of the circle for all those circles? It is the same. Thank you. It is the same. So concentric circles are just circles that share the same center. All right, circles that share the same center. All right. So in this case, you're just, again, like you said, you're adding one more circle. All right, you're adding another circle. All right, now number 5. Somebody, number 5 is kind of tricky. Tell me, Sebastian.
So when you add the number behind it, 6 plus 3 equals 9, 6 plus 6 15.
And
15 plus 9 is 15.
you are exactly correct. The next term is the sum of the previous 2 terms. All right. 2-1. Page 111. All right, that was good, by the way. All right, very good. Anybody have any questions? The next term is the sum of the 2 previous terms. Okay. Number 6. Somebody else. What's the next term?
Like
Multiplying by
you add 4, you multiply it by 2, and
add 4, multiply it by 2.
what if we multiply that? I remember you.
Say it again now. You're right. Multiply by what? And then add what? Add that number. You were close.
You add 2.
Yeah, multiply by 2 and then what? Add 2. Right? 2 times 2 is 4 plus 2 is 6. 6 times 2 is 12 plus 2 is 14. Everybody's good now? So then the next term would be, yeah, 126. All right. That's for some reason, that's just hard for kids. You know what I mean? You just have to mess around until you get to it. All right.
I just did multiples of 4. I do add 4.
That's what I was asking. You can come up with a different way. So you're saying 4, 8, 12. Uh-oh. But then it doesn't work anymore, does it?
Why not multiply by 2? So 8 times 2 is 16.
And then what?
22. And then 64.
All right. So I'm happy with that, but tell me again now because I don't see it.
Um,
What am I doing? Multiplying by what? Because there are different ways of doing it. I can't. You said something about the multiples of 4.
oh, like,
So you think about it, because I do want to know if there's a different way.
why is it like, so 2 to 6 is 4.
2 to 6 is 4. Okay, I like that.
4 times 2 is 8, and times 2 is 8. And then that's 16.
Oh, that's what I'm saying. There you go. All right. So I see. So you're multiplying 32. So the next one would be 64 and 64 plus. Yeah, you're right. That does work. Started with 4, 8, 16, 32. So you doubled the multiples of 4 and then you added it to the previous term. That's what I mean. There's lots of different ways. Very good. It's exactly correct. All right, very good. All right, so that's what I'm saying. You see it differently. You're allowed to see it differently. Come up with the same conclusion. All right, so the product of two even numbers. We have to make a conjecture about the product of two even numbers. What's going to happen if I multiply two even numbers? It's going to stay even, right? The product of two even numbers is even. There's actually a way to prove that. All right, but we won't worry about that right now. Now, you're supposed to give a counterexample if it's false, right? Is there a way, is there two even numbers multiplied together that you can think of that's not even? And the answer would be what? No, I don't think so. Agreed? All right. What's the relationship between A and B if A and B is equal to 0? Say it. A and B has to be 0. All right. So that's her conjecture. A and B are 0. Now the question is, does that have to be true? No, it doesn't. What can we say?
Negative.
A is equal to negative B. All right, I like that. All right. Now, what are those called, though? Remember from your algebra days? Additive inverses. A and B are additive inverses. But you're right. You can say A equals negative B. I'm totally happy with that. You could say B equals what? Negative A. I'd be happy with that. And it is true that A and B both could be what? 0, but they don't have to be. Right. That's the thing. All right. That's pretty easy, right, guys? All right, let's look at the next one. Oh, this is good. The relationship between a set of points in a plane equidistant from point A. So here we go. So I'm going to make a plane. Try to anyway, but my iPad is acting up. So let's try that again. All right, so there's my plane. And now what I want you to do is I want you to make a point. And I want you to visualize all the points equidistant from A. So I'm going to place a point over here. And I'm going to place a point over here. Do you agree that's equidistant? What about, make this a little bigger. So, do you agree that point's equidistant? Is that point equidistant? What about that point? So come on, tell me when you know what I'm making. Say it. Yay, very smart. That is correct. All right, the relationship between a set of points in a plane equidistant from point A forms a circle. Believe it or not, that is the definition of a circle. All the points in a plane equidistant from another point. All right, that is called a circle. All right, let's see how good I was. Wow, perfect as usual. All right, so almost perfect. All right. Let's look at 10. The relationship between AP and PB if M is the midpoint of AB and P is the midpoint of AM. How am I supposed to know what that is? I have no idea. So what am I supposed to do? Draw it out. Yes. You're not supposed to just look at that and say, oh, that's obvious. All right. You're just not supposed to do that. That's the problem with some. They just want to look at it and say, well, obviously that's the answer. Right? Just like my circle is not obvious until you start drawing things and you draw it until you put enough points. You can say, wow, they're just creating a circle. That's what you're supposed to be doing. All right. So now let's look at number 10. All right. Here we go with number 10. The relationship between AP and PB, if M is the midpoint of AB and P is the midpoint of AM. Man, I have no idea. So I'm going to draw something here. And I'm going to put down A and P. And now I have to put P and B down. But does it say that they're on the same line? Does it say they're on the same line? So could I put B over here? Yeah, I'm going to put B over here just because I'm not sure. Because I don't want to leave anything to chance. So the relationship between AP and PB, if M is the midpoint of AB and P is the midpoint of AM. So if P is the midpoint of AM, right? P is the midpoint of AM. It says that, right? So then I have to put M right here. Does everybody agree with that? Then it says M is the midpoint of AB. So now does that mean that B is on the same line? That means that it's on the same line. So now I have to extend this out. And I have to put B far enough away that M is the midpoint of AB. Now, to mark that, of course, it's a little annoying, but I would mark this equal to this. Everybody agree with that? And then I'm coming over here and drawing this, and I like to draw it this way, and I can put 2 tick marks here, and then my eyes can see what's true. That's how you mark the figure. So what's the relationship between AP and PB? What's the relationship between AP and PB? Someone please tell me. I'm listening. Very good. AP is 1/3 of PB. Everybody okay with that? Now, the reason that is because if AP is X, then PM is what? Help me, guys. If I said, I'm trying to get you to visualize this. If AP is X, what's PM? Also what? And then MB is what? 2X. Thank you. Come on, join in the class, guys. I know it's early. All right, seriously, you guys, we're going to get up and start running in the morning. All right, before class. We're going to go out in the gym. I'm going to make everybody run 10 laps and do 10 push-ups. And then we're going to come back to class. All right. You think I'm crazy? You watch. All right. If we don't get participation, that's what we're doing. All right. All right. Now, here we go. That's AP. This is PB. So AP is 1/3 of PB. Thank you, Sebastian. All right, is everybody good with that? Drawing it out makes a difference. That's what I'm trying to show you. Drawing things is important. All right, so now let's find out about 11. Okay, so now pull out your handy dandy calculator. Come on now, I'm trying to see. All right, yes. Yes, you can. You can borrow Super Coots. All right. So here we go. Is it dead? Okay, just come grab one of these over here. Yeah, this one. Maybe that's why he gave it to me. He wanted me to charge it or something. Just grab one of those. Just untape it and give it back to me. Or that's going to be somebody's. Oh, actually, you know what? Do me a favor. Put that there. There's one in the closet. Go in the closet. All those, because those I have to mark still. You with me? So hustle into the closet. You look on the right in there. There's a box of calculators. Just grab one. All right, keep going. You see it? All right, just grab one. Turn it on. Make sure it works before you come out. All right, now, everyone, listen, this is always on the SATs now. All right, always, always, always. And I think those of you guys who are good at calculator use have a tremendous advantage over kids who do not know how to use a calculator. All right, so I want to help you use your calculator. All right, so I need everybody to pay attention. All right, we are going to actually plot these points. All right, we're going to plot these points so you can look at it. All right, so I want everyone to hit the stat button. And we did this last year, so it's not, you know. And then after stat, we have to edit. And then L1 and L2 should come up. Does everybody agree with that? L1 is probably the what? X values, correct? And L2 is probably the what? The Y values. Everybody with me on this? All right. So now what I want to do is, do I really want to plug in 2010 or is it okay just to plug in 10? Let's do 10, right? Let's do 10. All right. Then we would just know that we're talking about 2010. All right. So everybody's under L1, type in 10, 11, 12, 13, 14, 15. That's what we're doing. All right. Then under L2, you're typing in 62, 93, 122, 145, and so on. Is everybody agreeing with that? Everybody's got it? You good? Anybody have any issues? Nobody? All right. So now what I need you to do is this, guys. I need everyone to go to y equals. Everybody's going to go to y equals for me. Right? Now above y equal is a stat plot. Everybody see that? You want to turn it on because your calculator, you want your calculator to be able to graph the points. Is everybody with me? So did everybody turn it on? It's got to be, it's going to highlight to dark. All right. If it's light, that means it's not on. Is everybody good with this? All right. Now that you've turned that on, I want you to ask me questions now. I mean, everyone's allowed to ask me questions. All right. So please don't be afraid. All right. It's annoying. It's hard. I understand. And I'm doing just visual and you hearing my words. All right. So we turned it on. All right. Now, if you hit graph, nothing should come up, right? There's no points on there. Does everybody agree? And why are there no points? Because the points are outside the graph, correct? We're plotting 1062 and it only goes up 1010 right now, right? So now what I need everybody to do is go to zoom, hit the zoom button. And then if you go all the way down, all right, there's a zoom stat button. I think it's 0, correct? 9, all right, zoom 10, 0 is zoom fit. You're right, thank you. So it's 9. So if you hit 9, what magically comes up on your screen now? All the points. Exactly. Does everybody see that? Right, so your calculator's super powerful. Now, do you agree it's linear? Right? No. Come on, Tanner, raise your hand, say what happened.
I don't see that.
See what? Did you hit zoom stat?
Yes.
Did you turn your stat plot on when is that us? Okay, guys, we'll finish this up tomorrow, but everyone else, the rest of the problems I want you to do. All right, is everybody with me on that? All right, I'll help you finish the calculator tomorrow. Remind me, please. I appreciate it. Good job. Thank you, David, for helping him, by the way. Yeah, we'll finish it tomorrow in class. If you know how to do it from here, yes, the rest is homework.